guys, so let's do some sample problems. The first problem I want to do says, an astronaut on the planet Zircon tosses a rock horizontally with a speed of 6.75 meters per second, and the rock falls a distance of 1.20 meters and lands a horizontal distance of 8.95 meters from the astronaut. What is the acceleration due to gravity on Zircon? So, whenever we're doing these problems, I would always like us to write out the variables, because as long as you write out your variables, I promise it will help out tremendously. So if I write out my variables here from that problem, I see that my velocity in the x direction, a horizontal velocity, is 6.75 meters per second. I know that the range, or ultimately, my projectile landed 8.95 meters from that astronaut. And we can assume then that it just started from zero. Now, my initial y, I'm dropping this, so my initial y was 1.20 meters. It's going to hit the ground, so then that means that it's going to land at 0 meters. And my y velocity is going to be 0, and my y velocity is 0 because the problem says that an astronaut tosses the rock horizontally. So if I'm just tossing it in the x direction, then I'm not going to have an initial y velocity. So that's why that y velocity is going to be 0. So I have my variables written out. The next thing I want to do is try to figure out my equations that I want to use. Well, I know that for my x component, we're going to use that x equals my initial x velocity times time. And then I have my y component equation, kinematic equation, that we're going to use here. Now, my goal is to try to find the acceleration due to gravity on Zircon. But I have a problem. I need to find g, but I also don't know what t is in this equation. So I'm actually missing two variables there. But I have x, 8.95, and I have that initial velocity in the x direction, which is 6.75, so I could solve for t using that x component equation there. So we're going to do that. So I did that here. Our x was 8.95. Our initial velocity in the x direction was at 6.75 meters per second, and then we're going to take that times t. If I rearrange for t, I'm going to get t equals 1.33 seconds. So now that I have time, I can plug time, that 1.33 seconds, into my y equation that I wrote down here. So if I do that, I'm going to get my 0 meters is equal to 1.20 meters plus 0, pretty much just 0, 0 times time, then minus 1/2 g times my time squared. So if I plug all of those numbers in, I end up getting my Zircon gravity to be 1.36 meters per second squared. And I got all of that by using these two equations here for projectile motion. So I didn't know time in y because my goal was to find g, but I found time using my x equation. So again, found time using that x equation, and then I could plug in my time to find g, that acceleration due to gravity, by using this equation here. Okay, let's go to the next one. So that was a problem where we see that there's a horizontal velocity, but I didn't have an initial y velocity. So what happens if it's a non-horizontally launched projectile? So I'm launching it at some type of angle. In this problem, we have, and this is a very standard problem on an AP test. An object is thrown off a cliff from 50 meters high with an initial velocity of 25 meters per second and an angle of elevation of 30 degrees. How far away from the base of the cliff will it land? Okay, so based on my problem, I know that my initial velocity is 25 meters per second. and that's at an angle of 30 degrees. I don't know what my x component, I don't know what my initial velocity is in the x direction, and I don't know what my velocity would be in the y direction. But I could find them by using trig functions, sine and cosine. So that's what I did here. So if I'm looking, if I need to write, or if I need to find my x direction velocity and then my y component velocity, my x component would be my 25 meters squared times cosine 30, because these would be adjacent, and then opposite would be y, so my velocity in the y component would be 25 meters per second times sine of 30 degrees. Well, we also know that it said that it's accelerating at 10 meters per second squared. I know that the initial position was 50, and then its final position will be 0. And then I can just assume that in the x direction it's just starting at 0. We like to assume that a lot. So we can just, again, use our x and y equations. So here I had x equals my initial velocity in the x direction times time, and then I had my, again, y equation that we've used. So I plugged in our variables here, and when I did that, I got x equals 21.7 times time, and then we have my y, which is 50 meters, plus 25 times sine 30 times t, minus 5 meters per second squared times time squared. Well, I have a problem because I don't know time. I can't find time here, but I do know a way that I can find time here. I can find time in this by using the fantastic quadratic formula. Woohoo! Okay, so if you use the quadratic formula to find time, remember that time is a positive entity. We don't have something like a negative time. So I always want to take that positive value that I find for time in the quadratic formula. If I do the quadratic formula, which you should do, then, and I take the positive one, I get time to be 4.65 seconds. So I get time to be 4.65 seconds. Now, my problem asked me to find how far away from the base of the cliff will this object land? How far away from the base of the cliff will this object land? Well, if they're asking me how far away it's going to land, then that means that they're asking for range. And range means that I'm asking for that horizontal direction there, which means I'm just trying to find x. So x is going to equal 21.7 meters per second times time here, which I found using my y equation and then using the quadratic formula. .65 seconds. So then that means that my x value is going to be 101 meters. So that means my object was 101 meters away from the base of that cliff. Okay, so they can give you on your AP test problems with just the numbers. They want you to do some number crunching. They want you to show that I didn't have time in either of these, but I could use the quadratic formula for this to find time to then find the range. So they want you to show some type of problem-solving skills using numbers. That's great. But they also want you to show that you understand things conceptually, even just by using variables. So I have another one, but before we do that, I want to make sure that we have a good idea, that we know what we're doing. So I would like you to now, if you would first by yourself, try to do these problems. So it says playing shortstop. You throw a ball horizontally to the second baseman with a speed of 22 meters per second. It says the ball is caught by the second baseman 0.45 seconds later. So first part, how far were you from the second baseman? And then B, what is the distance of the vertical drop? I want you guys to try to do this one by yourself first. And then if you think that you have it, and then your neighbor's done, try to check with your neighbor, see if you got the same thing. If you didn't, I want you to compare your work. I think it will be good for us to kind of see different alternate ways to do things. If someone messed up, I mean, we may have had just like a little minor error somewhere just with math. So try this first.